In this video, we're going to take a very brief look at using AXIEM to simulate MIM capacitors or MIM caps in a MMIC design flow. The folks at Win Semiconductor have been kind enough to allow us to use their kit. This kit in particular is the PL1510 kit, for those of you familiar with Win. And what we're going to do is look at a couple different configurations of how we can incorporate MIM cap AXIEM simulations or MIM cap EM simulations into our design. We're going to start off very simply here where I just have a MIM cap that I've drawn 100 by 100 microns. Now, one of the things you need to know about the Win PL1510 process is this process is really optimized for doing millimeter wave design. So we're very interested in frequencies, let's say, in the 30 or 40 gigahertz range. So when we sweep AXIEM in this range, we're going to expect to get our most accurate results here. Real quickly on this EM structure, what I've done is just simply drawn the MIM cap using the P-cell generator or the cell generator for the geometry in the kit, and I've applied ports on the lower plate here. Port 1 is on the lower plate. Let's zoom in the corner here, and you can see that the port is actually placed on the lower plate there, and there's, according to the design rules for the process, a certain amount of overlap that the two need to have to draw the MIM cap or to render the MIM cap properly. On the top plate, port 2 here, let's zoom in on a corner, and you can see that I've got port 2 here on the top plate. When we look at the simulation, I'm going to compare this to the model in the kit. So this is an extracted model based on measurement. And again, one of the things you need to be real careful about is to understand where this model's been extracted. As I mentioned earlier, this is a kit that's been optimized for millimeter wave design. So we would expect our results to be highly accurate, let's say in the 20, 30, 40 gigahertz range as I'm showing here. Down low, we're going to sacrifice some accuracy. Now this may be because of the measurement itself. When it comes to calibration, depending upon the calibration used, it may not be as accurate here based on the data taken. The data may not have been taken this low. That's something you need to check out with your foundry provider, or when you're taking the data yourself, you need to be real careful about where you're going to measure data, and also on the other side, how you're going to model it. If you know that the model is going to be used in the millimeter wave region, then of course you want it to be more accurate there. But if you need it lower down in frequency, let's say below 10 gigs, you're going to want to optimize the model here. So we're showing very good agreement. This is a percent across the S parameters. And you can see for most of the useful range of this device, we're talking less than 0.1% error here. So this is a very, very accurate model, and AXIEM's giving us a good representation of it. Now, another thing that we can do is we can actually use the MIM cap more in a circuit type configuration. So here I'm feeding it with microstrip lines, and because of the AWR bridge code capability, the bridge code automatically knows whether the microstrip line is going to attach to the bottom plate here on this side or to the top plate, and you can see the bridge code's automatically drawn the air bridges, again according to the precise rules that Win has for how air bridges are drawn. And here we can kind of infer that there's an air bridge rule for maximum width, and so the MIM cap bridge code has broken the air bridge up into two distinct regions here. Also, you may have noticed that I'm using the extract block. This is going to automatically, when we have it enabled, it's going to automatically create that EM document for me and incorporate it back into the S parameter measurement or the linear analysis that we're doing here in the schematic. I have it deactivated, so what we're going to do is I've already extracted the EM document as I've shown here, and we can look at the extracted mesh that's being created, and I'm going to go and compare that to this document when I do the accuracy. Just like I did for the cap alone, I compared it to a simulation for the model. I didn't show you what that schematic looks like. Here I'm showing you that schematic. We're going to compare the two in our accuracy measurement, our accuracy plot. But before we do, let's go ahead and take a look at how this is being meshed by AXIEM. A couple interesting things to note. First of all, we're using the 3D capability of AXIEM, both in terms of measuring the MIM cap itself, but also in terms of measuring the metal. Here's that microstrip line. We're using a thick metallization in the Win process where it's actually going to stack up those metals, and you can see that we're actually meshing in 3 dimensions. These sidewalls here are going to be calculated, and we're going to get the fringing effects of having that thick metal. But if you also look at the air bridge itself, you can see that we're meshing that in 3 dimensions. Let me zoom out a bit and we can get a better look at that. You can see that we're also going to mesh that in 3 dimensions. So there's going to be some 3-dimensional effects here of this coupling to the sidewalls in Z of this air bridge here back down to the metal here, but we're also going to get this coupling down to the bottom plate and through the dielectric itself. So some very complex electromagnetic effects going on here that are going to be important to us, or we'd at least anticipate that they're going to be important up into that 40 and 50 gigahertz range. So let's see how AXIEM did. Well, when we compare it to the extracted model, you can see that we kind of get that accuracy that we expected, but the accuracy isn't quite as good as what we got with the MIM cap alone. Now, part of this could be due to the fact that we're using the Emlyn model, which does not have the same level of accuracy that we would expect with the measured data that we've matched for the MIM cap itself and with the AXIEM results. So down low here in frequency, we're going to see some extra error that gets incorporated into this. If you'd like more information about how to do this type of simulation with AXIEM, if you'd like more information about the WinKit, or if you just like more information about Extract or anything that you've seen here in the AWR design environment, you can go to awrcorp.com or contact your AWR sales professional.